Okay.
Mute your mic.
All right, you have to guide it. My mic is muted. I'll also turn my sound down.
Where's the mouse? Oh, sorry. Oh my God. I hate Keynote UI.
All right, so Lewis, how does one,
Can you do that? Sorry, can you?
you know, I'm just gonna close this.
Yeah.
Though it's too bad we can't see the people on Zoom.
No, I can't even move it there. Keynote is.
Oh, there,
Oh,
they're
wait.
there. All right, great.
But now I can't move it. Wait. Oh my God, I can't even see my cursor.
Yeah, that's kind of standard, and it only happens when you're presenting in public and everybody has shown up. And you're ready to start. All right, well
Okay.
done. So, Louis, what's the cue that it's Louis and not Louis?
It's a French name. I just go by the English pronunciation. It's
All right.
it's a style choice. So
So Louis is a prospective grad student in Ellie Pavlik's lab, and there's Ellie. And we're all hoping that he comes and is around a lot more.
I already accepted the offer.
Oh, you did?
Yeah.
Oh.
Incoming. Yeah.
All right, well, have a brownie. Better have a kosher bread.
I've been given so many cookies today. I can't.
All right.
Okay, so this is an introduction to narrative
Maybe
theory
Ellie wants
from
one.
the perspective of model and information theory. I went into university, wanted to be a novelist, and the natural thing for a novelist to want to major in is pure mathematics, obviously. And I wanted to make computers tell stories. So I finished my undergrad in pure math with like a focus on like algebraic topology, model theory, geometry, and then decided that I wanted to go back to storytelling. And the mathematics of storytelling is vastly underdeveloped. There's only like maybe 6 or 7 papers in the entire field. So it seems really right for like a mathematician's eye.
That's the best kind of field, right? Where you only read 6 papers.
Yeah. So, oh my God, give me. I'm sorry. I'm just gonna.
That's all right.
Sorry, Albert. I'm gonna move you. Okay.
You could just minimize that.
So why do we care about computational narratives? So, yeah, and then even now, wait, sorry, I hate this UI. Narrative theory allows us to discuss communication dynamics between the authors and readers. For example, we can reason over, we can use this reasoning to reason over infinite sets of possible worlds in a finite matter. Effectively, it's formal semantics with like extra constraints. So the constraint being that there needs to be like a time-dependent dynamical system. So we'll get to that in 1 second. But overall, it's also massively underexplored, and there's a lot of cool things that you could learn just like dipping your toes in narrative theory. So, what are we solving? A reader, when consuming a story, reasons about potential an infinite number of story worlds. So how do we describe the space of possible story worlds? What can we do with this framework? We can do a lot of fun stuff with this framework. A lot of fun stuff. We'll get to that shortly. We can start deriving like information theoretic balance. You can start discussing evaluation metrics for story coherency. You can start talking about like reinforcement learning and stuff like that.
So, Louis, you got to remember you're speaking to a bunch of psychologists here.
Okay.
So, can you say a lot more about what you mean by we reason about potentially infinitely many story worlds?
So, at the crux of it, right? The main crux of like computational storytelling is that you want to talk about like counterfactual reasoning between an infinite number of potential story world candidates. So I'll get to like precisely what that means in a moment. But like if I tell you the queen died, the king is sad, or something, right? That's like typically the example that people use in narrative theory. Well, just by telling you those phrases, you have an infinite number of story worlds that could match that story. So how do you determine which story world is the most valid? How do you determine which story worlds are coherent? How do you determine like which story worlds are actually relevant to the story and which ones are like just extremely out there?
Does that make sense, everyone?
Mm-hmm. So what is a story? The definition that, oh, sorry, can someone like tell me if like there's questions? It's
in the chat?
Yeah.
I can sign in and monitor the chat.
Well, I'm already signed in.
So- what is a story? The definition of story that people typically think of, is the hero's quest and like the 7 archetypes and stuff like that. But a story is much more broad than this. A story is like any summary of like some dynamical system over time. So anything, any like set of knowledge that changes over time by providing
Sorry.
by providing a summary of this knowledge, you're effectively doing storytelling. And the reason that you have a definition this broad is that it includes most modalities of human communication. It includes data visualization, it includes novel writing, it includes movies, it includes music. It's a lot of things. So it's also useful to discuss what isn't a story. So any summary of a system that doesn't change over time, or it's constant, if there's no change in knowledge about the system, like the world state doesn't change, then you're not discussing a story. So if I just list off random facts, if I just list off 1 + 1 = 2 like 100 times, I'm not telling a story. I'm just listing off a constant system. So directly stating the entire system with no form of compression is also not a story. If this is hearkening to the data visualization side of storytelling. So if I just give you the raw data and I don't do any form of visualization, I'm not telling you a story about the data. I'm just directly handing you the entire system. So data points is not a story, but a visualization of those data points might be.
So the interesting implication there, I think, is that the world never tells us a story.
Yeah, the world inherently never tells you a story. You have to summarize the world to find a story. So you effectively have to compress some system to find a story. And by compressing, you're introducing your biases. The stories are always inherently biased.
Can I ask a question? Is it any kind of compression that's
So
is okay? So if I said the lights were on and then they were later blue, or then they were later off,
So
is that a story?
the precise definition of summarization in narrative theory is really, really hard. And there's like entire books written on just that.
Mhm.
I'm not really a it's considered summarization. What is it? But more or less, it's if the summarization that you see looks like a story, then it's probably a story. That's kind of the definition that a lot of people in narrative theory use. And it's kind of dumb, but
So would you consider the height?
yes, I would consider that a story. So can we formalize the notion of the story? Sure. So in the components of the story, we have the
It keeps changing for some reason.
is my mic like being really weird?
No, do you have your iPod still?
Oh, okay, putting those there. Did it change from my?
And it went back to the house.
Okay.
Can people still hear Louis? People
Yeah, it sounds good now.
Okay,
Yeah.
okay.
I can hear.
So how can we formalize the notion of a story? So there's 2 main components to the story. There's the fabula, which is like the raw characters, the events, the spatial context, everything. If you were to write down every possible fact about a story, it would be a fabula. So fabulas are typically like causal graphs that represent the story, or it's a time series of knowledge graphs, effectively a time series of knowledge about your story world and how that knowledge changes with respect to like certain characters, certain actions, certain plot points, stuff like that. And then you have a sujet or a discourse, which is the medium by which the fabula is being condensed. So a sujet or a discourse is like the text that you're reading, it's a movie that you're watching, it's music, it's stuff like that. So a novel, a poem, a song, or an intermediary representation, because you can have multiple sujets in a row, meaning like you write a novel, you turn it into a song, you turn it into a movie. Those are all each individual sujets, but the entire thing is also a sujet. But wait, there's so much missing. So these definitions don't inherently require story arcs. They don't require suspense. They don't require major plot points, minor plot points, because the definition that of stories that are accepted is very, very broad. So storytelling is just a function to condense these complex interactions over time. Adding all these extra structures provides us with more interesting stories that are more interesting to study, but they're inherently more complex and not the main focus of narrative theory. So what notions can we get like without adding all these extra structures? So we can start to model the reader and the author. We can start to model the rules by which the fabulas interact. This is referred to as the language. And we can model that information is transmitted from the author to the reader. This in particular proves to be surprisingly useful because we can start constructing evaluation metrics. We can start saying, this is what it means for a story to be coherent. This is what it means for a story not to have plot holes and the like. So let's start rigorously defining what a story is so that we can start building out a framework. What structure can a story rule take? A language is a set of rules for forming syntactically valid propositions. So if you're familiar with first order logic, you have and, you have or, you have negations. These are all symbols of language. But you can also add different symbols. For instance, you could add symbols for character intent. You could add symbols for causality. You could add symbols for like time and stuff like that. These are not inherent to first order logic, but they might be inherent to a kind of fabula that you want to describe. So what are all the possible logical statements that we can say about a story? And what are the causal relationships that could exist in our world? They're just two kinds of examples of the things that you can put in a language. So a story world model, S, over a language L, is comprised of two main parts. We have the domain, which is the objects in our story world, which is characters, events, spatial locations, objects. And we have the interpretation function, which maps logical statements about those objects to those objects. So if we say that character X is happy, right, then we need the interpretation function to map character X to an actual character in our story, and then we need it to map happy to some state in our story, which is like a description of happy. A causal, so if we go back to the notion of like causality and stuff like that, a causal graph's interpretation function is a function that maps vertices element of our story world model domain. And then the next definition, theory of a story world is the set of all propositions about that story world that are true. Typically, when we talk about story worlds, we like to talk about the theories rather than the story worlds directly. The story worlds aren't entirely that useful. We'll get to that in a bit.
So far, this just seems to be a logic. Like, I'm not sure what the difference is between.
It's extremely similar to formal semantics, except you just add the temporal structure. And by adding the temporal structure, you get a lot more things that you can use. So by being able to discuss the communication of information over time, you, for instance, get to discuss like how a reader is reasoning about the story that the author is receiving, and how a reader is able to connect plot points over time, how a reader is able to.
Where did the temporal structure get added?
I'll get to that in a moment. Right now, this is we're just assuming that we're telling you a story in a single fixed time frame. Like the author is giving the entire story in like one time step, which is very unrealistic, but it's much easier to define it this way than to define with temporal stuff. So defining fabulas is a bit harder. There's no real rigorous definition of fabulas that's commonly accepted. Typically in practice, one defines a fabula as like a causal graph, but this doesn't really provide many insights into the core attributes of what a fabula should be, or like what kinds of fabulas make sense for storytelling. So at the end of the day, a fabula is effectively the scratch pad for the story world model. So it's the things that the author or the reader writes down like in their brain while either consuming a story or literally writing a story. It's the part of the story world model that's actually relevant to the storytelling. So if we use this intuitive notion of fabulas, we can come to the next definition, which is that a reasonless fabula for a story world model F is a set of propositions that make claims about S. A logical statement contained within F is contained within F, and a reasoner deems it important to accurately representing the story world. So if the reasoner says, given my biases, right, this statement is required to portray this notion of the story world, then that proposition is put into the fabula. You still have these DAG structures between these propositions, but effectively the fabula is the first step of compressing. It's the first step that an author takes to compress this really rich, massive story world and put it into something that eventually can be written into a story. At the end of the day, it's the narrative scaffold. It's where the reasoner takes notes while they are writing down the story.
So how logically coherent does it have to be?
So we assume.
So let me say what I mean. I'm thinking like Dave Rumelhart way back in the day before he invented connectionism, studied stories, and he had this great example of it went something like it was, Sally had a party. All her friends came and gave her presents. And he showed that people assume there's a cake and that, you know, the kids are all dressed up and that they're balloons and that it's Sally's birthday. So there's all of this underlying, all these underlying assumptions are
So
made.
there is a very particular structure that we'll get to in a few slides, just to account for that in specific.
So this, the fabula itself,
It
doesn't have to be entirely logically
The
coherent.
fabula has to be coherent from the perspective of the author. So if the author writes down a fabula, in the author's brain, it has to be coherent because it assumes the author's internal biases.
But authors always have hidden premises.
Yes, but like if we didn't get to this yet, we'll get to this in a moment. We're assuming that the authorial intent is entirely known, that there's no hidden authorial intent, meaning that like there's no hidden biases, there's no like unknown biases. You know everything.
But are there unknown facts or?
But the unknown facts, like if it's unknown but not inherently required for the story, then it's in the story world model and not in the fabula. It's a really weird definition that's the few papers that have actually been written on computational narrative theory are specifically on how do we best represent fabulas, and it's very, very nuanced, and I kind of have to skip a fair number of details. We can get to that at the end if there's time.
Okay.
So as I was just discussing, we'll assume for this presentation that the narrator is solely the implied author, that the authorial intent is entirely known, and that there is no hidden biases of the author. So in this case, the narrator and the author become interchangeable, which is not typically accepted in narrative theory, but it's an assumption that's required for some of these, some of the following work to work. I mean, eventually I want to fix this, but not yet. So we're going to walk through a diagram of how storytelling works from the perspective of commutative diagrams. So in the narrator story world, for instance, the story that we're going to discuss is the queen is dead, the king was sad. So in the narrator story world, you have all of the things about the kingdom, you have all the things about the state of the queen before she died, all of the things about the king before the queen died, and all of the things about the king after the queen died. Then you have all of these like little minute facts that aren't inherently required to tell your story. So when the author, the narrator, decides to compress the story world to the narrator's fabula, we get these statements. The queen died implies the king was sad, which is one potential fabula. We get the queen died, comma, the king was sad, or just different well-formed formulas to represent this fabula. There's a number of ways, there's different compression functions that get used. We won't entirely go into that. But the discourse then takes the fabula that the author and the narrator has written and writes this out in a text form. So when you have the discourse, you literally write down the queen died, the king was sad, which then gets consumed by the reader, and the reader constructs their own fabula. So the reader now writes down a set of minimal well-formed formulas in order to represent the story. So maybe the reader doesn't think that the queen died. The reader doesn't think that the queen dying is the reason why the king is sad, so they don't directly come to that conclusion. So now the reader has a different interpretation than the author or the narrator, and this is totally allowed by how the discourse and compression functions are working. But then the reader expands these statements given their internal biases. So they have their own internal set of biases that act on this fabula in order to update their story world model. So their story world model, after receiving these statements, might say, oh, well, the king obviously loved the queen, and the queen died, so the king became sad. Maybe in the narrator story world model, actually the king hated the queen, and the king was only sad because he stubbed his toe or something. So you can have very different biases resulting in different stories. And if we look at pure to the ideal story conveyance, it would circumvent the entire difference in biases, and the narrator, the author, would be able to directly convey the entire story directly into the reader's story model. but obviously this isn't feasible in practice. This isn't really something that's ever feasible. So you have to go through this whole loop every time to represent, to trying to, in some cases, ignoring artistic direction, try to get to the ideal story conveyance.
Doesn't that just depend on the type of writing the author's doing?
Of course.
So like,
Yeah.
I mean, like, it's quite like children's stories are very easy to get the ideal story because you're filling in the gaps for them.
But then that comes down to the narrator's biases. So the narrator's biases are that they want this story to be conveyed perfectly. Then then this whole route will be very close to the ideal story conveyance.
So the narrator didn't have biases, and I missed that. I thought we were like making for assumptions that there are no biases.
There are biases, but the biases are known. That the assumption was that the authorial intent is known, but there is authorial intent.
I'm not following. I mean, this isn't really my area, but I guess if the authors or the narrator's biases are known, then you should know the correct interpretation because you should know which intent they had when they said.
Oh, okay. So
Yeah.
okay. So the authorial intent is not known by the reader. There's no hidden ones. There's no. The author is not trying to trick the reader. This is what it comes down to. If that makes sense.
But many times this is a resource used that is very successful. No, he knows we're going to draw some inferences. That he says,
Oh yeah.
the queen died, the king, la, 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 la.
Yeah.
He's counting on these inferences that we're going to
Yeah. Of
draw,
course.
although he's not committed to them. But
Yeah.
they are. I mean, they are a big part of a good story. The fact that the reader is going to
So
feel
that-
this part that is
That
not.
goes back to the notion, like, I mean, it's not, to give an example, it's not entirely this, but if you go back to the notion of like suspense, right? We're assuming that in this framework, like, we don't really have to deal with suspense because the authorial intent is known, right? So if the author says the dog was blue, there's no plot twist, there's no reason why the dog was blue, it's just that the dog is blue. It's a very dumbed down version of storytelling because it's very, very hard to build up the framework to include suspense, to include arcs, until you have this very sturdy foundation.
And in one sense, should we understand idea story conveyance? Because this looks like you're going from the narrator story world to the reader story
Yeah.
world. But nonetheless, we are seeing that many times it's a positive thing, the fact that the reader draws some
Oh yeah, of course.
influences that
Of
the
course.
author is not committed with them, but they are going to provide a lot of
Yes.
surprise afterwards, for example.
So I see what you're saying. I think it just comes down to ideal. Ideal is a misnomer. It shouldn't be called ideal. I should probably change that. Okay.
This looks a lot like information theory.
It is, and we'll get to that in a second. You can derive metrics of entropy on this.
It looks a lot like abstraction.
That as well. It's a weird version of formal semantics. It's like formal semantics and narrative theory had a child, is what it comes down to. So I don't have time for this. You're right. There's no time component. What an observant audience. If we model a fabula over time, we can begin to model how our story worlds will change over time. So this was getting back to what you were saying before, where before we were assuming that the entire story happens in one time step, but now we're going to start assuming that like it's almost a game that's being played between the two agents.
So you wrote this slide while you were talking.
Maybe. So going back to the picture before, it's the same diagram before, it's just stacked going backwards, and we have zeta R and zeta N. And zeta R is the reader's transition function, and zeta N is the narrator's transition function. So it's exactly the same before. Going down is compression, going up is expansion, meaning that the reader is expanding the fabula that they've received from the discourse into the story world. And at the same time, they are trying to measure how the fabula is transitioned over time. And then the narrator, the author, actually knows how they intend the fabula to transition over time. So there's a lot of cool stuff about showing the faithfulness of zeta R to zeta N, and that's in the paper that this presentation is based off of. But they cover it because it's a really annoying proof.
Well, can you, I'm confused by this picture. I no longer understand what the author is doing. So the author is decompressing, is expanding
So the author-
fabula.
So the author at every step is compressing these story worlds into their fabula, right?
Yeah, then where's the transition come in?
The transition is that the fabula transitions over time. So you can't really talk about the story world transition over time because the story world is inherently infinite structure. It's not really something that's particularly easy to talk about how it transitions. So at the end of the day, like if you were an author writing a story, you have some finite set of statements that you want to talk about, and you are transitioning those finite set of statements using zeta n. Whereas
So zeta n is part of the story.
zeta n is how the reader is progressing the time of the story, how time is literally progressing in the reader's story.
Okay. But how does that get communicated from the author to the reader?
Well, it gets communicated from the author to the reader because the author will communicate various discourses at various time steps. So we can assume, like here, for example, maybe a discourse D is one paragraph about the fabula at that time step, right? So then we have like time step equals 0, and then we transition one step, then we have time step equals 1, and we have 2 different paragraphs, which is 2 different time points in the story, right? And this is not like story time within the story world. This is a literal time that like the reader is reading. So this is not like, oh, you have a flashback, you have to go backwards. This is like literally like I read paragraph 1, I read paragraph 2. So it's
So the transition is implied by the difference between these 2 paragraphs.
yes. So then you have zeta r, which is the reader's transition function, and zeta r is inferred over what the narrator is trying to convey. So zeta r might not be entirely faithful. Zeta r might actually be incorrect, but zeta n is always correct because it's direct to what the narrator is trying to write.
So does the time only depend on the narrators?
Yeah, the time entirely depends on the narrator.
So it doesn't, depending on the medium of information transmission, cannot the reader or the consumer of information also have an impact on that? So for example, faster reading
Yes,
speed,
and I really
faster
wanted
processing speed.
I really wanted to write a paper about that, and it got stuck in limbo, and I haven't finished it yet. I know, it's really exciting.
But for now, you're
Yes,
just
for now,
iterating,
yes,
yeah.
yes. I started, it's really hard to do model theory, and I only started this line of work about a year ago.
Can I ask a clarification?
Yep.
Which is, does the story world change over time, the narrative story?
Yes, the narrative story will change over time.
But it doesn't make sense to have any transitions between those
The only,
states over time.
the only reason why we don't have transitions between the states over time is that it's just not. So at the end of the day, we're trying to actually model something with this framework. We're trying to use this for something more empirical, right? And if you're talking about how these like probably uncountably infinite sets are changing over time, it's not something that you can easily model or use for evaluation. I mean, theoretically, you could discuss transition functions between these, but it just didn't really make sense in this framework, given where I was trying to push things. Any other questions with this? Okay. So now we have an informal notion of possible worlds. So given a fabula, there's an infinite number of possible worlds that might satisfy. So for instance, the example I gave before, the dog is a Labrador is a singleton fabula, meaning a fabula of a single statement, but there's an infinite number of story worlds in which the dog is a Labrador. You don't know what dog you're referring to. You don't know, you might not have a notion what Labrador is. Maybe Labrador here refers to the place in Canada. Maybe Labrador refers to the species of dog. I mean, a little weird actually. But which of these are correct? All of them technically. We can't really eliminate possible worlds until we start receiving more information. So we have to go back to the notion of storytelling over time. The purpose of zeta in the diagram before, going to here, zeta r and zeta n, is to expand the number, is to compress the space of possible worlds because you're receiving more information. So when you receive information from the narrator, you can start eliminating the set of possible worlds, and you can start to prune what the possible worlds that you need to consider are. So the reason for this is the set of possible worlds is all possible worlds. So like if you have the dog is the Labrador, then you have all possible completions of that story. So there's no actual way to for zeta to expand the number of possible worlds. So it always has to contract. So continuing this psi, which was over here, is an expansion function, meaning that it considers all possible worlds, whereas zeta restricts the image of psi to only a subset. So the example that I like to give is before clarification, I had big N possible worlds. After clarification, I have little n less than big N possible worlds. So we can, is this the same thing? Just 1 second. Oh, no, this is okay. Sorry. So we can recall from the prior figure that psi takes this new fabula and expands it into a number of possible worlds. And this the story worlds with the fabula is correct. So this gives us a notion of belief versus knowing. And I should have cited the paper on this, sorry. But knowing effectively means that a statement is true in all story worlds. So it's something that is taken as ground truth, whereas belief means that it's known in the majority. So we'll get to rigorously defining majority in a moment, but this notion of majority versus all lets us begin to define priors for possible worlds. And we can get to the more information theoretic side of things, and we can start talking about these information theoretic metrics. So in order to discuss notions of majority, we first have to start defining a few model theory terms. So an ultrafilter is what you use when you can't actually have probabilities. So there's no sensible way, at least theoretically, to define probabilities over these possible worlds. You can do it empirically and you can create heuristics, but there's no accepted notion of probability here. So ultrafilters are a way to size up infinite sets. If you have the natural numbers, ultrafilters are how you say that there are twice as many natural numbers as there are even numbers. So even though they're both infinitely sized. So they're defined over partially ordered sets, particularly ordered by inclusion, where like at the top of the post set, you have the entire set. At the bottom, you have empty set. I have a diagram right here. So assume all the colors are just solid green. This is the wrong diagram, but I couldn't find the right one. So the bottom is the empty set, the top is the total set, and these are partial ordered sets, partial ordered subsets ordered by inclusion. So we have empty set 4, 3, 4, 2, 3, 4, and then the total set. And the ultrafilter here, we'll get to in a moment, but it's this green part, which we will rigorously define. Next slide. So a power set lattice, PL, is the lattice of post sets ordered by inclusion, and given a set S, the power set lattice, PLS, an ultrafilter UF, is defined as for all X in our power set lattice, which was this entire thing, not excluding the colors. Either X is in the ultrafilter or the negation of X is in the ultrafilter, meaning that, for instance, here, either 1, 4 is in the filter, which it is, or 2, 3 is in the filter, which it's not. Or either 1 is in the filter, which it is. Well, oh, this isn't a total. That's why it's light green. Oh my God. Okay. This diagram is kind of wrong, but this
Tell us what you're trying to do with this notion of ultrafilter.
so what we're trying to say at the end of the day is that we can, actually I might have it on the next one. So we can start talking about how these possible worlds relate to each other. We can start saying that we can order these possible worlds by inclusion, and we can start saying that like these possible worlds are the possible worlds that the reader is considering, and these are possible worlds the ones they're not. Because a reader would not consider a possible world in the negation of that possible world.
So why do you need an ordering? You just need a binary distinction.
You just need the filter.
You just need what could be descriptive of the story, what possible world the story could be describing, and its complement. Why do you need an ordering beyond that?
Well, the ordering is useful because, for instance, if you go back to the diagram, right, if we have like 1 and 1, 2, 3, we already know that we should have 1, 3, and we already know that we should have 1, 2. those are both valid possible worlds as well. So it means that we can start discussing like minimal spanning sets. We can start discussing which finite sets generate the entire set of possible worlds, which we'll use later on for the information theoretic stuff.
Can I ask you a question? If you can hear me, maybe the background noise. I'm wondering if one can consider, for example, these ordered sets. One can think of like each element as a sentence and try to use the fact that the definition is ordered to represent, you know, the world of a narrative as kind of an ordered set of values or something like that.
I'm not entirely sure I follow what you mean.
I'm trying to just, I'm trying to think of how one would connect this to a story that is written in text, right? And I'm trying to think of how like the ordered nature of these filters that you're mentioning would relate to the like temporal progression of a story that is written in sentences, for example. Does that make sense?
I think that's what we're all struggling with, Bubik, so thanks for giving it
Okay.
an effort. You want to know how this corresponds to stories.
So this is particularly about the story worlds. There's no inherent ordering on the text. You can only really order these story worlds because from the model theoretic side of things, you can order these notions of models. You can order these notions of like, well, yeah, you can literally order the notions of models, meaning like you can order like sets of Boolean statements and stuff like that.
Is it fair that this isn't temporal ordering, this is a containment ordering, right?
Yeah,
Like
this is
every world in
yes.
which Fido is a dog and Fido lives in Connecticut.
Yeah, is a subset of like
the world
the
in which
world.
Fido is a dog.
Yes.
Yeah.
Isn't each edge an entailment? Like the
Yeah.
world 1, 2, 3, 4 entails the world 1, 2, 4.
It is an entailment ordering.
But
Entails our set lattice is equivalent to the belief. Under certain constraints, it's equivalent to the entailment lattice. So it's literally the entailment ordering.
But onto the temporal ordering of stories. Go on,
Yeah.
and maybe it'll become more relevant later. I think
Yes.
like I feel like we're getting hung up on it. is my
Yeah.
sense. Yeah.
It, it does relate to the temporal ordering in a way because you can define ultrafilters for every time step. So every time step of the story has its own ultrafilter.
Right. Okay. Yeah.
So we went over this. Okay. So the possible worlds form a lattice. So given a set of possible worlds, there exists a possible world S prime that differs only by a single axiom. So a single like minimal proposition that can prove like a large number of other propositions. So this lets us define a partial order set of possible worlds. And if a possible world is an ultrafilter defined over the lattice of possible worlds, we say that the reasoner believes in this possible world. This is just, there's no real reason, it's just we're defining it this way because it's a nice tool to have. So we can order beliefs by inclusion to describe a pseudometric, which we'll get to in a moment, and we can use UFT to describe the sets of belief held by a reasoner at time t. So this is where the temporal component comes back. So we're not actually dealing with, within the ultrafilter, there's no real time component, but you can define the ultrafilter over time. So if we want to start talking about information theory, great, now that we have a pseudometric, how can we use this? So we need an equivalent form of entropy that we can use. So let's take a step back and assume that rather than dealing with ultrafilters, we can now describe probability. So if we have a probability space, we can say, given a story S and a question of the form, if A then B, where A and B are both well-formed formulas under S's language, and a prior gamma about our story worlds, which is a prior about the possible worlds that we're dealing with, then we can define the relevance of B to A as the difference of their entropies. And this is this is a notion from formal semantics about the entropy, the relevance of questions to getting a certain answer. So it's just, I think this might actually be pulled from Knuth, from like one of his earlier papers. I didn't know Knuth did information theory until I wrote this paper.
Real quick, what's H in this expression?
With what?
What's H in this expression?
Entropy. And then AI and BI are either just true or false because these are Boolean statements.
And what's R?
R is just our function, it's a relevance function. So it's a function that we're defining over A, B, and our prior. So it's saying, we're asking like how relevant the answer of B is to knowing A. And we have our prior of possible worlds. So in practice, what do these kinds of questions look like? If A is true and the story is B true, or particularly in like doing like psychology experiments with stories, prior to this event occurring in the story, did you consider B? This is like something that I've actually used in practice a number of times. So we're measuring the faithfulness of a reader's story world's recreation. So how effectively is the reader recreating the story world from the information portrayed by the author? So we need a little bit more of a framework before we can start getting to like how we can use this in practice to evaluate the coherency of stories. We need a notion of an ultraproduct, which very intuitively means that we have a large number of possible worlds, and all these possible worlds can say whether or not a Boolean statement is true or false. And we say that if it's true in the majority of possible worlds, then the ultraproduct says it's true. So if the majority of possible worlds say that the dog is blue, then the dog is blue in the ultraproduct. So this notion of majority is very hard to rigorously define. If you really want to see, you can look it up on NLab. It's a really gross proof. I don't really recommend it. But we can denote this notion of majority over time as well. And we can say the ultraproduct of the ultrafilter at time t. And this proves to be extremely useful for constructing finite structures out of these very, very infinite sets, which we'll get to in a second. We need to go back to information theory. So can we talk about entropy over infinite sets? Not really, but kind of. But what we can say is if something is true in the majority, then it has to be true with the probability of 1 minus epsilon for epsilon greater than 0. And if we can say that the things that are true in the majority can be described by a finite set of well-formed formulas, then we can start empirically dealing with this information theoretic metric. If the set is infinite, then we've kind of lost all hope. But in most empirical cases, it is finite. You can construct really weird counter arguments, but they're not stories that would naturally occur. So going back to story coherency for a second, story coherency is a very tricky topic. Typically in practice, story coherency occurs as a disagreement in bias between the reader and narrator. Very rarely is a plot hole that a reader writes just straight up like and X, negation X. It doesn't really occur for most like professional writers, but I mean it does occasionally. So most plot holes of interest to narrative theorists are the ones that occur simply by differentiating biases. There's no real theory of what a plot hole is and what's just artistic vision or suspense or stuff like that. It would be a really fun paper to write. I really do want to do that type of theory of plot holes, but I haven't had time. So we need to assume a tiny bit more finite structure before we can get to the main result. So given an ultrafilter at time t and an ultraproduct defined over this ultrafilter, we say S is the finite spanning set of well-formed formulas. So we say S is the finite set of well-formed formulas that can prove everything in the majority. So if our majority is implications of the dog being blue, then S is simply the proposition that the dog is blue. So we want to measure how complicated the story world is at some time t. This should be a function of the size of S, and it turns out that it is. And we need to measure at the end of the day, though, how relevant each element of the story is to S. How we want to measure how relevant each element of S is to the story. And then the expected value of that relevance actually gives us a notion of complexity of the story. So last two steps before we get to the result. We need to expand the ultrafilter to say that we can talk about the reader's ultrafilter and the narrator's ultrafilter. Similarly, we need to talk about the majority of the ultrafilter for the reader and the majority of the ultrafilter for the narrator. And we can get to the result. So we can say that for some well-formed, So we want to represent the things that are true in the majority of possible rows with a finite spanning set. So we define the probability of Q as 1 minus epsilon if and only if Q is implicated by the reader's majority, 0 otherwise. But if Q is implicated by the majority, this means that we can use Q to construct the correct question of relevance. We can expand Q to the well-formed formula if A then B, and we can see that by doing so, we can then compute the expected value of relevance as the binary entropy of PQ. So we to bring it back to story coherence, it entirely comes down to the method by which you construct Q. So if an implication is in a reader's spanning set, if implications in the reader's spanning set imply the implication of the narrator's spanning set, we have perfect coherency. So we can use this to create a formal metric of coherency. So for instance, if both the head and tail of Q are implicated by the majority of the reader's ultrafilter, then the average should be 1 minus epsilon. So that's like our upper bound. The expected value should be the binary entropy of 1 minus epsilon, because that's like our upper limit for coherency. Anything less than that, and we know that the story is in some notion incoherence. So there's a bit of a fun aside, which is that this metric actually works in practice, and we have a number of CogSci experiments validating it, and we show the statistical significance. I'm happy to do a second talk on it. It'll also be a bit of a bear, but it'll be a lot of fun.
So those studies with the human participants involved saying, here's a story. What assumptions did you make that weren't explicitly present in the text?
Yeah, and then we look at the entropy of those assumptions. So we look at how many people answered yes, how many people answered no, and then the entropy of those answers gives us a coherency metric.
So let me ask a question about what it means for a statement to be in a reader's spanning set.
Mm-hmm.
There's certain things that I naturally consider, right? Like if Dracula enters with his blood dripping from his fangs, then I assume that he has bitten someone.
Mm-hmm.
And I know that I've assumed that he has bitten someone.
Mm-hmm.
But then there are all these other hidden assumptions I make, like that someone was probably a person.
Mm-hmm.
Didn't have to be, but was probably. And I certainly assume that Dracula.
So the notion of the ultraproduct, right? What is that something is implicated by the ultraproduct if it's basically something that you're actively thinking about. If it's
have to be actively thinking.
It has to be something that like you go, oh yeah, that's obvious, like right away, because you don't really need to like reason over it, because the majority of your assumptions would apply.
No, wait, but that's different. So I might actively like I can very quickly say, if you say, did the person that Dracula bit, were they vulnerable to gravity? Then yes, absolutely, right?
Yeah.
Gravity was right, but I wasn't actively thinking.
Sorry, actively is the wrong word, but that exact example would be contained within the majority. So that would be something contained.
So it doesn't have to be something.
No, it does not have to be misspoke a little bit.
It just has to be a property of the model that you're using to understand the text.
Yes.
And it's independent of how conscious you are of the fact.
Ah, man, that is a rabbit hole. I'm scared to answer that.
I'm not Dracula.
Oh my God. I'm open to exploring that more. I'm really scared to answer that question though.
No, but it's important, right?
It's a very important question, but I really don't know the answer. So for future work and notes, so the original paper that this proof is from is towards a formal model of narratives. And we have another example there where we talk about the faithfulness of our transition function by looking at these similar questions when we ask the reader to predict ahead in the story beyond what the narrator has wrote. So there's also a few projects in Limbo about measuring how wide the communication channel is between the narrator and reader. And by looking at like the moment generating function of these metrics, that's like really in Limbo. No, I haven't touched that in like 8 months. And then we can begin to model the process by which the readers reason over information by the author by considering like didastic readers or didastic authors. So what are the mental processes that these agents use when consuming the story? And in that case, the author is no longer the reader because the authorial intent can't be known. So we have conclusion. Computational narrative theory is almost entirely untouched. There's a ton of cool work to do, certainly more than a single PhD. And it's like formal semantics, but better. And here are my pets.
That's the moral of the story.
Yeah. How do I stop sharing? Sorry.
See that red button at the top?
Oh,
Where's this stop share?
yeah, that would be useful. Okay. Okay, so I guess questions? Anybody? Oh, questions? No? Okay.
Well, I have another question. So it seemed like the logic didn't include causality.
Not inherently. It definitely could be expanded to include causality. So I kind of think that the framework that I was working in is more general than causality, being that you can include causality in the language that you're modeling, but you don't inherently need causality because there's a lot of kinds of narratives that might be told without causality. It's because you can assume that like a narrative might be like the data visualization example that I was giving before.
Yeah, I mean, you talk about generality like it's a good thing.
No, well,
right, but
but-
really what you want is precision to understand what kinds of inferences.
I do agree,
people make.
but this is mostly focused on like very simple like foundations, and like given these very simple foundations, can we still do anything meaningful with it? It turns out you can. I'm very happy about that.
So how would you include causal motion?
I would include it under the language for the model, and I would probably also use the assumption that our fabula is a DAG, because the fabula would probably take a causal graph structure in nature.
Sorry, the assumption that the
Then a fabula is a directed acyclic graph.
Oh, I see.
Yeah.
So when you give the example of the queen died, the king is sad.
Maybe I should still share, so I have that up.
That's fine.
Okay.
Because you were talking causally in that example, right? You
Yeah.
said like, and maybe the narrator
Yeah,
says
so
that these are unrelated, but then the person refers. that they're
empirically, when you're discussing stories, the fabula naturally takes a causal graph structure. It's very, very hard for you to write the story where the fabula isn't a causal graph. You can do it, but it's probably some weird degenerate case.
So what is the like? I'm trying to like draw the lines between, so you have your story worlds, which are defined over this language where you included, like you can have symbols for, you said causality in that language. So you might have a story world where the king's being sad was caused by the queen dying, and you have a story world where it's not.
Yeah.
Right. And then you have the causality encoded in the fabula via the directed graphs.
Yeah.
And then you would have perhaps the causality rendered in the actual natural language story because you say because, or maybe it's implicit just because of things. So I guess I got lost in exactly, so me as a reader, like how do those things all follow through? Is it that once I take the language and I render it as a fabula, that's where I commit to this causal thing?
Yeah, so you commit once you've included it in the fabula. But like you can, at that point, when you include it in the fabula, you can still use it to eliminate possible worlds.
Right.
Meaning that you might commit to it, but it's still, your commitment gets used to eliminate all like some massive proportion of the worlds.
Right. Okay. And then, so when you said like, in order to include it, you would include it both in language and by making fabula directed graphs.
Yes.
Like, couldn't you skip one of those? Or couldn't you skip making the fabula directed graphs and you could just rule stuff out otherwise?
Well, it's just the intermediary representation. It just comes down to that in a lot of cases, it's easier to work with the fabula than it is text. Yeah.
Right.
So one question that has come up in the psychology of narratives is, do people represent temporal structure and infer causal structure from the temporal structure, or vice versa, right? Do people represent causal structure and infer temporal structure from the causal structure? And it's one of the few questions in cognitive science in which I believe there's a very clear answer, which is that people represent the causal structure and infer any temporal structure from that.
Mhm.
And in fact, there's lots of evidence that people don't have a good sense of the temporal structure of stories directly, but they have to understand the causal structure,
Yeah.
because that's what it means to
So
understand. the
when we
story.
wrote this paper, I had a cognitive scientist on the team who gave me a very similar talk, which is why the time component doesn't actually represent time within the story. It represents time like consuming text. Yes.
Oh, so you're not actually representing time. within
No,
the
we're not
story.
representing time within the story. You'd have to expand in that direction, and it was very, very tricky, and I was kind of scared of doing it. But it could be done.
But don't you need to? Like, what if, the house existed at time 1, but then a missile hit it and it didn't exist at time 2? Right? Like, how would you represent that?
You could still have that, but like the thing that you couldn't have in this framework is flashbacks, right? It doesn't permit flashbacks because it assumes effectively that that at every time step you're eliminating a number of possible worlds. But if you're having a flashback, it could be that you're adding possible worlds. You have to assume that time only moves linearly in the structure.
Yeah, I just had a question when you mentioned the plot holes. And you had something on like it cannot be that it's A and not A at the same time.
Yeah.
And that's the rare cases, but authors do make mistakes.
They do make mistakes. But
So sometimes, so what would that imply for example, exactly the same thing that I just mentioned, that the theory does not address the possibility of re-emerging some additional possible worlds if the character was described as having green eyes, and then later the author made a mistake and it's like she or he had like blue eyes or brown eyes or whatever, and there's a contradiction. And now like what does that say about I restricted the set of possible worlds and now like, I'm
it would
contradicted, right?
mean that you'd have to add back, and the framework doesn't allow for that.
So what does happen based on the theory you worked out now when there is a contradiction like that in the information transmitted?
I kind of haven't gone into that. I mean, I definitely do think though that you would have to add the possible world. So effectively what you would have to do is you'd have to have both the time component for in the story world and reading, and then you'd also have to have like a repair function.
Right. I mean, that would have been another question, right? Because also you mentioned, the communication channel medium, so that's also a big part of information theory.
Yeah, of course.
Like how you have methods of error correction and
I actually
recovering lost information.
was going to expand this to include repair functions, so you could begin modeling like editors and stuff like that. And we have a very empirical result for this. Actually, a bunch of the authors are in the call right now, which is a little funny. But it was called Cut the Carp, Fishing for Zero-Shot Story About, where we start like trying to represent notions of authors and how like an author might react to certain like parts of a discourse and stuff like that. And but the theory wasn't really advanced enough to account for this kind of repair. It would have been a very, very daunting task to expand the theory far enough so that we could have discussed the Cut the Carp paper in this framework.
Anyone online have a question or a comment? No? All right. Okay, well, thanks so much, Felix. Appreciate it. So, we will see y'all.